Right, good evening, everyone. I hope you had a wonderful weekend. Short, but it's acceptable. Right, today we want to continue with our discussion on developments, and we are going to focus again on transition pieces. So let me show you what we are going to look at today regards to our lesson. But remember, I explained a lot with regards to what transition pieces are. So for today, we are going to look at the copying of the given views and construct the surface development of the transition piece when you are given the scene. Right, I also intend to show all the constructions that are necessary in order to come up with that development. Besides, we are also going to show fold lines as dictated by the question. So I want you to follow the steps so that you'll be able to apply these on your own. As always, my emphasis is on doing. So I want you to be practical with this subject. Everything that you do, make sure you are able to apply on your own, right? It will not help you by merely listening or seeing someone doing it. So you need to be practical. Take your drawing board, take your paper, take your pencil, and do the same exercises as well. I hope you enjoy this lesson, and good luck. Right, just as I explained with my introduction, right, we are going to look at the transition piece, right, and especially this part, which is the transition piece, right, from a rectangular prism, which is far much bigger, and from a square prism to another square prism, but the sizes are different, and also that the transition part is drawn at an angle, okay? So it would appear a bit oblique, so we do not call this one right, but it's an oblique transition piece. Right, let me just read the question for you so that you also be able to follow. Draw to scale 1:1 and in first angle orthographic projection. Right, the front view and the top view of the given portion of the ducts, right? So this is the top view, this is our front view. Remember, if it is in first angle orthographic projection, what you see from the top, you draw at the bottom of the front view. Develop the surface of the transition piece only, make edge AB the seam, show all necessary constructions. Right, so for now, I'm going to copy the views, right, before we start explaining as to the details. Right, and as you can see, right, we have got this square is 30, this one, right, the smaller one is 30 side, the bigger one is 50, okay, and the other information is given as follows. So I'm going to draw that here. Let me measure 50. Right, that is the first square. Then the other one is, like I said, it is not directly on top of the bottom one, right? Which means I would require 65 from this point to that point, right? I would measure 65. There you go. Right. So this one is 30, which is 30 as a square, right? And this point connected to this point. There you go. Right. I can outline this now. There you go. So the big square is 50 in terms of the side. The small square is 30. Okay. Right. Once you have done that, right, I can create a ground line here, right, like that. Label this one X and label this one Y. Right. Have the starting position like that. Right. From here to there it's 15, from here to there it's 50, from here to there it's 15 again. So I need those measurements. Right, I can take my pen for outlining. There you go. Right, so I've copied the given views. That's the front view as well as the top view. The next thing that I want to do, right, is to make sure that I can label this, right, as you can see, right, with regards to this, what we are given, right, is the seam line. This is point A, this is point B, okay? Right, so that's point A, that's point B. But I want to change this setup in terms of the labels. I'm going to say this is point 1, right, so this is point 2, this is point 3, and this is point 4, like that. The upper parts, I will label them with digits. Then the lower parts, all right, I would say this is point A, this is point B, this is point C, and this is point D. So I've got A, B, C, and D, 1, 2, 3, and 4. Okay, right. Once I've done that, the next thing is to create triangles. Okay, right, triangles such that this surface, when I'm looking from this side, I'll be able to see, say 1A and 2 as a triangle. Let me just do it. Like that. Right, okay. Maybe I can use a red pen to define this. So show by way of dotted lines. Okay. Right. So that is a triangle where the name is derived from, triangulation. Right. Then from B, I also join to number 3. Like that. Right. I have got 2 triangles, this one as well as that one, 2B3 and 3BC. Right. Then from C, faintly best. Sorry about that. Right. That's another triangle. Right. 3C and 4, 4C and D. Last but not least, I can join this one now. There you go. Right. So I have defined my top view according to triangles. Okay. Right. We have got this. This is your point D, right, which is in line with point C. Right. This is your point A, which is in line with point B. Right. This is 1 and 2. This one is 4 and 3, like that. All right, just when we are looking from this side, we can see that there's a line all the way from D to 1. So we can show that one as well. We can show this one, right, faintly. Right, I would show this one. There you go. Okay, right. So this line D1 is the same as that one. Right, okay. Now, the next thing that you would require to do once you have set your diagram like this, right, is now the need for you to find the true length, okay? All right, remember last time I used the concept of rabating or the cone generator method. Today I want to use another one, which I believe it's much easier and faster as well, right? Now, what is critical in terms of the true length, right? You need to have this height on the front view, right, from here to there. So what it basically means is that you can even draw this one at the top, right? Or anywhere where you are able to fit the true length. So I'm going to create a line here, right? Create a line like that, which is just a perpendicular line. Then do the same, right? Here, I will just make use of this line, which is already there, okay? Right, let me start with this line, right? 1 to A. Right, there is a similar line to 1 to A, which is this one, okay? Right, so I'm going to show by way of a small little line like that, and this one. So 1A is the same as 2B, okay? Right, 1A is the same as 2B. Right, I'll take right, I'll take the distance 1A. Let me adjust my canvas. Take the distance 1A like this. There you go. Right, this is 1A, which is the same as 2B. Right, come and stand here, right, and mark like that. Then connect. This one to there, like that. I can also, again, make use of this one using a different color. Maybe let me use a pen. Like that, okay? Right. So this, I would say this is point 1, right? This is point A, which can also be point B, okay? Right, or you could simply write, this is 1A, which is also 2B, like that. Right, so that's the true length, okay? The next true length that you want, right, is A to 2, which is this one, like that, which is point A to 2. You stand at the start point, right? And you describe a mark like this, okay? Right? Or I can even take it this side so that I won't disturb with where I'm going to write later on in terms of my drawing or my development. Right, so standing at this point, I've opened to this side. I'm going to do this. Right, faintly first. I'm going to show it differently. Okay, right, this line is A2, okay? I'm going to write here, that's A2, right, such that if I've got point A and I've got point 1, I can establish point number 2. Right, the next one that I require is B3, okay? B3, right, which is not the same with any other line. But so I'll take this B3, like that, right. I can even use this, but maybe let me concentrate on this side, B3. Okay, let me use this like that, okay. Right, connect this one to there. as long as the height is the same, right? So you can also show it like this. There you go, okay? Right, and this is B to 3 or 3B. So B3 like that. Right, the next one that I require, right, is 3 to C. 3 to C, right, which is this one. Stand here and connect to the height. Right, as you can see, 3 to C is the same as 4 to D. So I can come here and show it like this. This one, it's just 1 and show it like that. Then I can also show it like that. But for the sake of being able to identify, this is 3C, which is the same as 4D, like that. Right? Remember, you can write 4 here as well as 3 there. Then at the bottom, you have got C and D, whichever way that would make it easier for you to identify the lines that you are working with. All right, okay. Now, I do have this one and that one. The other one that I will require is this one, which is 4C or C4. Right, like this. Now, I don't have much space that side. Let me see if I were to stand here. Connect it to there. There you go. Use a different color. Just like that. Right, I would say this is C4, okay? All right. The next one that I require is D1, but which is very long, right? You take it from here, you open to this point, okay? Right, let me see if I stand here. Okay. Which is the point here. All right, but always know where this is connected from. I can take it to there. Right. I'm crisscrossing like this because I don't have much space to work with, right? So this one is D1, okay? All right, now I have got all my true length, right? Remember, when true length are established without necessarily projecting by rabating like that, you need to write, okay? I will just write this TL, right? Diagram like that, right? You can also come here and write TL diagram like that. So you are directing the examiner to say, this is where I got the true lengths, okay? So the examiner would check, okay, linking these points like the last one, if you were to check this, which is that. So if you stand here, you open to there, you have got now the true length from here to there. Once you have done this, the next thing that you want now is to make use of those true lengths that you have established. Right. Remember, you are given a specific starting position, which is 1 to A. Okay. Right. If you have got enough space, you can start by drawing at that particular angle. Okay. But if you don't, right? You can start anyhow, right? Just vertical like this. So I can start from a vertical position, label the starting position point number 1 like this. Point number 1, right? Then take the true length of 1 to A, right? Which is 1A. That is the true length. You can measure or you can make use of the canvas like that. So stand at point number 1, then describe an arc like this, right? So what you have established is point A, right? Once you have gotten that point A, you can even outline it, right? I'm going to use a red pen like that. So now that is my first line in terms of the development. Right, I've got point A, I've got point 1. The next point that I would require to have is point number 2, right? Now, is this point number 2 a true length? Yes, because it is seen as a point in the front view. So you take 1 to 2, which is a true length, right? You stand at point 1 and you describe an arc like that, right? Then you take the true length A to 2, right? A to 2, right? Which is this one, from this point to that point. So I'm going to take this, which is the true length, right? Stand at point A and describe an arc like that. Then you can join this to them. Like that. So that is the first half panel, right, in terms of the triangle that you have devised, right? So the true size of this triangle is from 1 to point number 2, which is here, right, and back to point A, right? There are certain details that can be outlined. I can outline this from here to there, right? That is possible to outline. Then the next one that we require is for us to have point B, okay? Right, point B is as a result of standing at point A, that's 2 to B, as well as A to B, right? Whenever you are dealing with triangulation, it is important that you establish a common point from 2 standing positions. So the common point here is point B, 2B, A, B, okay? Right, AB is a true length because it's seen as a point here. So I would take AB, take AB, stand at point A, and describe an arc like that. All right, the next thing, you stand at point 2 to B. Remember we said that 1A is the same as 2B, so I can easily come and take this one, this size, right? Stand here and describe an arc like that. There you go, you have got point B. Point B is now established. Then you connect A to B. Right, remember I said I would outline the cut lines, the outside lines, the red pen, this. Then let me define the fold lines using a blue color. Like that. Right, so that is the first panel. When you are looking from this side, this is what you'll be able to see. Right, that's exactly what you'll be able to see. Right, then from there, what I require now is point number 3 2 to 3 is the same as 2 to 3. They are both parallel to the ground line, so they are both showing as true length. So I would take that 2 to 3. I don't need to go back there. Take this one, then stand at point number 2 and describe an arc like that. Right, somewhere on that arc lies point number 3. Then from there, I need the true length B3, right? Let me look for B3, which is here, from here to there. But that's my B3, right? Take the true length. Like that. That's the true length. Then stand at point B, right? Slightly shorter. Right, then let me go back to this one. And extend that so that they cut each other. Now I have got point number 3, right? I'll label that one. Connect point number 3 to point 2. Then connect this one to them. There you go. Right, I can outline 2, 3. There you go. Right, the next one that I require is now point C. Right, so I need B to C. Right, B to C is the same as A to B because it's a square. But I can take this one like that. Describe an arc. Right, BC is as a result of 3 to C as well. Right, 3C, which is the true length here. Right, take that true length like this. You take that true length. Let me put this one down. Right, that is the true length. Okay, you stand at point number 3, then you cut the first arc here, like that. The point that we establish now is point C. So now B is connected to point C, and point C is connected to point 3. Okay. Right. Once you have done that, check which line should be outlined, which lines should be shown, or which set of lines, or a line which should be shown as a fold line. So in this case, if you check, this is on the outside, so it qualifies to be a cut line. And this one, right, it's a fold line, right? So we need to show it the same way that we did with regards to that. So I'm going to outline this. There you go. And show this one as a fold line. Right, so as you can see, triangulation is just creating triangles, but as you patch them together like this, they need to be the true size of those particular triangles. So you can only do that by establishing the true lengths, okay, which is the first step that we did. Right, so I've got point C now. The next point that I require to have is point number 4. Right? Remember, these distances from 1 to 2, 2 to 3, 3 to 4, and 4 to 1, they're basically the same, right? Reasoning, it could be, right, if you're looking at 1 to 2 seen as a point, but which means this view is a true size, 2 to 3, right? And 2 to 3 this side, they are both parallel to the ground line, which is the XY line, so which would make them both true length, okay? This is equal to that, and this is equal to that. So I'm going to take, right, any one, which I've already defined here. this, describe an arc. Right, on this arc, I should be able to get point number 4, okay? Right, the point number 4, it should be, right, C4, which is this one from here to there. Right, I take that, C4, there you go. Right, stand at point C and describe an arc like that. So I now have the point number 4, okay? Right, I now have got point 4. Connect this point 4 to point number 3, right? Then the other one is connected to here, okay? The line to outline is 3, 4. There you go. So 3 to 4 is outline because it is a cut line. Right. Then from there, I need point D. Okay, so from C to D as well as D to number 4. CD as well as D4 or 4D. Remember, you always start with the established points. CD is a true size, so I'm just going to take from here. Right. Then stand, describe an arc like that. Then I need 4D, right? Which other line was equal to 4D? It was 3 to C, right? So instead of going backwards, right, you can increase your speed like that. Then you take it to point number 4, right? And you cut this, right? You now have got point D, okay? Connect C to D like that, and D to 4. There you go. Now, from C to D, this is a cut line, so we are going to define this one as an outline. Right, then from 4 to D, which is a fold line there, right, I'm going to show it. There you go, okay. Right, so we now have got 1, 2, 3, 1, 2, 3. These are the signs, but as you can see, this is not a right transition piece. In terms of its position, you'd find that it has got a skewed appearance, okay? But don't worry about that. You represent what you are able to see. So don't try to doctor it or to change the appearance because it's looking funny. No, just as long as you are able to follow the principles of triangulation, the shape would come out and it will come out the way it is supposed to come out. Right, the next thing that we want to have, right, is to establish point number 1. Right, we are almost coming back to 1A. So 4, 1, right, like I said, that's a true distance. So I can come here, take this distance, stand there, and describe an arc. Somewhere on this arc lies point 1, okay? Right, so I now need D to 1. Remember, 4, 1, D, 1. 1 is common there. Right, let me look for D1, right? Where is my D1? It's here, okay? Right, so I'm going to take this distance. Take this distance from here to there, okay? It's like that, right? D1, you stand here and describe an arc, right? To cut the first one, now I've gotten back to the starting position, which is point 1. Right, the next thing is to connect like that. And you also do this like that. Right, on your development, you should be able to see a series of triangles, right? That would bring about that concept of triangulation that we are talking about. So these triangles are necessary and are part of the drawing. So don't leave out these triangles. They are marks as well. So in an exam, you'll be credited for that. There you go. The last part in terms of our development that would require, right, is to find point A, okay? Find point A. Now that we have got point 1, which is this point 1, we can reach to point A. Since we have got point D, we can reach to point A. So the connection or the point of connection or convergence, it's 1A and DA, okay? So I need the true length 1A, right? Which is here, which is the same as that one as well. So I would take from here. Right. Stand at point 1 and describe an arc like that. Right. So that's the distance from this point to that point, which is defined by this true length. Right. Then you take the true distance, which is DA, right, which you can take from here, like this. Right. You stand there and describe. So the end result is that you now have got point A. Right. Point A is connected to point 1. Point A is connected to point D. Like that. Right. Then you outline. These are 2 cut lines. We no longer have a 4th line on the outside, so we are going to outline from here to there. Right. So this side from here to there is the same as that side, right? Which means if you are going to connect the 2, they should be able to match each other. Okay. Right. I'm also going to outline here. There you go. Right. So this is a typical development, right? When you realize that the side is not perpendicular, it's not upright, right? It's at an angle like this, right? Remember, you need, first of all, copy the given views to scale as shown, right? Establish the true lengths, right? Once you have established the true length, if you are given a specific opening point or opening line, which you refer to as the seam, right? Start with that. If you have got space, you can start that line at the given angle, right? So that it relates, okay? Or it could be this angle, which is fine, or it could just be any particular direction, doesn't matter. You can even start this line as a horizontal line, you still produce one and the same thing. Right, so this is how we establish, right, a development by the method of triangulation. So the last thing that you'd require, you need to label and write development, right? I'm not going to write the complete thing. Transition, piece. There you go. Right, so that is the development of this transition piece, which is defined by that shape that we are able to see when we are looking at the front view. Right, so boys and girls, I hope you were able to get one or two concepts with regards to the development of the transition piece. Right, I'm not quite sure whether we'll be able to start a new diagram now, because what I want is to make sure when we meet again, right, we are going to look at a transition piece, which has got a prism and a circular part. That circular part could be a cylinder, okay? Right, so our next discussion with regards to this would focus mainly on the prism, right? It could be a rectangular prism, it could be square prism, but which is connected with a circular element that is a cylinder. Right, boys and girls, I hope you enjoyed the lesson, and I wish to see you again tomorrow when we look at what I've just said with regards to our tasks. Good night.